you have to look at, well, what's the behavior of 1 over Zi? What's the behavior of 1 over Zf? And you'll find that one of them behaves like a high pass, one of them behaves like a low pass. Right? So if you look at these impedances individually, you're going to find that one looks like a high pass times a low pass. Right? So that's what this configuration allows us to do, is multiply two individual transfer functions to get an overall transfer function. So we're multiplying, in this case, a low pass times a high pass. So if you think about it like that, that's maybe another way that you can visualize it. Okay, can we move on to the two-port stuff? Okay. You're like, yes, I never want to talk about these perfect. Let's do my rejected two-port network question. For those of you that weren't here when I was explaining the story, this was the two-port network question I was going to have on the final that had rejected because it was too difficult. So if we can do this one, then we can do the one that's on the final. I don't know if we're on a mysterious board. We're going to have black mark last Okay, so given the following two-port network, we're going to come up with the Z parameters. You have a dependent voltage source over here, which is V times I2. You've got a dependent current source here, which is A times I1. And you also have a resistor R2 in parallel. Here's your V2. Remember, I2 goes in here. V1. I1 goes in there. So one thing that's not referenced on the diagram in the question that I'm doing here, I didn't have these I's in here because I think that you should know currents are always referenced going into the two-port network. So you know which side is one, you know which side is two. Just remember the currents always go inside. So the question says, solve for the equivalent Z matrix. And then we explicitly say, recall that V1, V2 equals Z, so that's a big matrix times I1, I2. So again, if you can't remember that, just pretend it's Ohm's law. So you just say V equals Z times I. It works just like Ohm's law. Same for conductance, you can say I equals Y times V. So let's work through that part. This part isn't too bad. This part actually ended up with a nice, concise matrix. So let me explicitly write those out. I always find this very helpful. This is just a suggestion from me. It's not a tip or a hint or anything like that. It's just what I like to do.
So, just by looking at the circuit, like how can we tell that we should use? It's easier to use Z or Z matrix or Y matrix, or
you're not. You were told to find the Z matrix.
But we can use A matrix or H matrix to.
You could if you felt that that was easier to do, but I think it'd be really mean to write a test, ask somebody to find something very difficult, and then have them convert it from a simpler form. Okay?
Yes. Are the matrix like provided in the formula sheet, or we have to remember all the A, Z?
What do you mean by is the matrix provided?
Like
Like
just
formulas.
the
What's sitting inside the
Yeah,
matrix?
yeah, yeah.
That's given, this is effectively given to you, right here. Z is a matrix, you just know that the matrix has 4 elements, right? So no matter what it is, in this case it's Z, this is the 1, 1 element, this is the 1, 2 element, the 2, 1 element, the 2, 2 element. So this here is sufficient to tell you the equations, right? The key thing that changes between all the matrices is what's on the left side and what's on the right side. That's the key thing that changes. So this here should be sufficient for you to expand those equations.
Yeah, I meant are those given, like on either side?
Yeah, it was given in the book. So let's actually break these equations out. This is what I was going to say before, is I find it helpful to actually write out those 2 equations in a non-matrix form, so just in an explicit form, equally Z11 times I1 plus Z12 times I2. Z2 equals Z21 times I1 plus Z22 times I2. So recall that to shut off a current, so I'll say shut off I, we must open circuit. Shut off V, we must short circuit. Alright, so in order to find these parameters, if you remember, it's easiest if you just shut off one half of the equations here. So we're going to find Z11, then we're going to find Z21, because we're going to reuse the information for Z11. And then what we do, so we shut off I2 by open circuiting that side. So we just leave it as drawn there, that right-hand side. And then when we want to figure out these parameters, we're going to open circuit the left-hand side, and we'll see how that works. So we're going to start with Z11. Z11 equals V1 over I1 when I shut off I2. And what I can say here is that I2 is off, right? We already said I2 equals 0. So I know that that dependent source is going to be 0. But let's write it out explicitly. So what I can say is the current going through that resistor is going to be V1 minus that voltage there divided by R1. So that's going to be I1 equals V1 minus V times I2 over R1. But since I2 equals 0, therefore I1 equals V1 over R1. Rearrange that, we end up with Z11 equals R1. So that one was pretty easy. If you saw that I2 was 0, you could just shut that off mentally, and you know that a voltage source that's off just looks like a short, right? So it just looks like R1 when you look in there. Okay, now remember that I like to go to the next one here, Z21, because I already have I2 shut off. So let's write this out. Z21 equals V2 over I1 when I2 is off. And now the nice thing here is that that's pretty simple, right? So we can express V2 in terms of I1. So if we can express V2 in terms of I1, which we can do because we have a dependent current source now, the I1s are going to cancel, we'll be left with something. So let's figure out what the voltage is through that little mesh up there. The voltage through here, if you think of, remember like that Thevenin and Norton stuff, is just going to be that current times that resistance gives you the voltage at this node. Because remember, there's no current going out there. We've set I2 equals 0, right? So it's going to be A I1 times R2. So we can say that V2 equals A I1 times R2. We'll sub that back in here. We end up getting that Z21 equals A I1 R2 over I1. Z21 equals A R2. So far not too bad.